determine the required magnitude of the couple moments M2 and M3. So we have couple moments here, M2 and M3, so that the resultant couple moment is 0. So moment 1 is 300 Newton meter. What are the values of M2 and M3 such that the resultant couple moment would be 0? Okay, so what we can do here is that we can draw an axis system XY for this problem, and we can actually move these vectors around anywhere within the system, because as we know, for a couple moments are free vectors. So recall that couple moments are free vectors, and we can move them anywhere within this XY space without altering their effects. Okay, so what we're going to do here, we're going to move all the couple moment vectors onto the origin here. So we have at a 45-degree angle an M2 acting 45 degree with the x-axis, so this is M2 vector, and it's causing a rotation like this. So assuming that this is pointing towards our thumb, so based on the right hand rule, so that is the rotation. And for M1 we have this vector here. Let's go and use a different color for the moment vector. So okay, so this is M2, so this is M1, and this will be M3. So I'm moving all the vectors from their original positions to the origin of this XY system, XY axis system. So this is M1 vector, and the rotation would be like this. Okay, and for the M3, the rotation would be like that. Okay, right hand rule. So that's the M3 vector, M3. Okay, so the resultant, now we are just dealing with vectors, and we want the resultant vector to be 0. So we can write, and for M2 the coefficient x component of M2, and then y component of M2. So this would be a vector like that, and this would be a vector like that. Okay, and this would be M2 times cosine 45 degree. This component would be M2 times sine 45 degree. Okay, so based on this we can write resultant vector, and okay, so M resultant, the component of the resultant vector in the y direction would be sum of the moments in the y direction, so that should be equal to 0. Okay, and that is M2 times sine 30 and minus 300. Okay, and from here we find M2 to be 424 Newton meter. Likewise, MRX which is equal to sum of the moments in the x direction components, or the vectors themselves. Then we can write a m2 times cosine 45. m2 is 224 times cosine 45, so it's this one, minus m3 is equal to 0, and from here we can find m3 equals 300 Newton meters. Right, so we have found m2 to 424 Newton meter and m3 300 Newton meter. And this concludes the solution of this problem. Thank you for listening.